So just like with IPv4, static routing is bidirectional. Sorry, static routing is unidirectional, which means that if we want bidirectional communication, we need to create two different static routes. So in this case, when I set up a static route on branch, it's unidirectional. When I set up a static route on HQ, it is unidirectional that way, creating bidirectional connectivity in the end. So if I only configure it one way, it's not going to completely work for us. So first of all, I'm going to create the static route from HQ back to branch. And there's the example we have down below for HQ. It says IPv6 route, then the network we want to reach. So in this case, we want to reach 2001:DB8:A01:/64, which is this network right here. So I've put that in. Now, what's the next option? Well, there's a couple of different options we have here. Number one is we could specify the global address. So the next top IP address here being the global address 2001:DB8:D1A5:C900:1. That's fine. It works exactly like this. We can specify an exit interface, but just like IPv4, specifying an Ethernet interface as the exit interface creates what is known as a directly connected network. And now that we have a directly connected network as the static route, the router is going to perform the neighbor discovery process every time it needs to forward a packet. And the result of that could be no communication whatsoever. So encapsulation failures occurring because as I use neighbor discovery process to get the MAC address for every single packet because I think it's directly connected to gig 01, some of those are going to go unanswered. Maybe none of them are going to go answered at all, meaning no communication. So we want to reduce the neighbor discovery process. So always use the next hop IP address. Now, where you might have to use an exit interface is when when you will have to use an exit interface if you're going to use the link local address for the next hop. So instead of using the global address as the next hop IP address, I could use the link local address as the next hop IP address. And if I do that, I also have to specify the exit interface. So I have to say, use gigabit 0/1 going to the next hop link local address of gig 01 over here. And the reason why you have to specify the exit interface as well as the next hop link local address is because you can have the same link local address on multiple interfaces on a device. That's right. So the link local address that's potentially used over here, well, I could accidentally have that same link local address used over here. That's a possibility. Or it could be reachable out this interface going to someone else on a local network. So the idea here is if you want to use link local addressing as next hops, you also have to specify in your static route the exit interface in order for it to work. If you don't specify the exit interface, the router will yell at you. So it's not something that you could potentially forget and cause a failure in connectivity. The router will yell at you. Hey, you specified link local address. Make sure you put in the exit interface as well, so I know exactly how to get to that next top IP address. But if you're using global addressing, there's only going to be one way to get there, and that'll be out that specific interface that you're directly connected to. So on branch now, we want to get to that server, but what we're using as an example here is a default route. So the default route, meaning if you don't know how to get there based on entries in your routing table, go ahead and use the default route and just go. Send everything out towards headquarters that you don't know how to get to. So the default route for IPv6 looks a little strange. It really does. Look at it, IPv6 route :/0. Now, why is that? Well, if you think about for IPv4, what did we have? We had 0000 space 0000. So that resulted in an address of 0.0.0.0/0. Well, with IPv6, what would all zeros look like? It'd be 0000:0000:0000, right? That's a whole bunch of zeros. Well, why not just replace all those zeros with a double colon? And then put our /0 prefix on it. So that means the same thing. :/0 is your default route. And there's our next hop IP address. In order to get there, it's the next hop IP address of this interface in order to get to everywhere else. Again, you could specify link local address. And if you do, you also have to specify the exiting interface in order to accomplish that goal. So now we have potentially connectivity here because branch knows how to get to everywhere else that it doesn't already know how to get, and HQ can get back to the network of branch. So let's check our routing tables first. Let's make sure on HQ we have the static route listed, and we can see here in this output that it's 2001:DB8:A01:/64 with an administrative distance of 1. So that hasn't changed for IPv6. The administrative distance is still 1, and the metric is still 0 because we don't provide metrics for static routes. And because we put in the global address, you can see the global address is the next hop IP address here. But if you would have put in a link local address, then that would show up here in combination with the exit interface that would be utilized in order to get there. So static routes are represented as S's. What about a static default route? Well, it's also represented as an S, but you'll recognize it as being :/0 in this case. So notice we have a 1 here for the administrative distance because it's what it is for a static route, and then 0 for the metric because we don't define metrics. And there's our next hop IP address in order to get there. So based on this information, we now have the ability to hopefully ping. So let's go ahead and test our ping. Ping 201:db8:AC10:100:64. That's the address of the server. And we can see that our ping has been successful in this case. So we can successfully reach that server. Something we might want to do here is change the source. So if we change the source in this case with our ping by adding on that option and then specifying a different source address like 2001:db8:A01 and whatever the address is of this router interface here, then we could test connectivity from that branch local area network up to the server and see if we have full connectivity at that point in time round trip.